All right, today we're going to talk about the standard form of a linear equation. So the standard form of a linear equation is ax plus by is equal to c, where a, b, and c are all real numbers, and a and b are not both zero. So a or b could be zero, but they're not both going to be zero. Now, the reason for that is, of course, if a was a zero, then 0 times x would be 0. If b was 0, 0 times y would be 0. And we'd be left with this equation of with no variables. It wouldn't be meaningful at all. Okay. Now, this equation is very useful in graphing in that it helps us to find intercepts. Okay. And to kind of start talking about those intercepts, let's consider what happens if only a is 0 or if only b is a 0. So let's imagine that for a moment. In this equation, let's focus on a. So if a was a 0, then 0 times x would just be 0. And then anything plus a 0 would just be itself. So we'd be left with this equation, which we could easily solve for y by dividing by b, and we'd get this. Now, c and b are just numbers, so c divided by b is also just going to be some number. So this would be the equation y equals some number. Now down here, they give an example of what that looks like. If I have the equation y is equal to some number, what that does is it creates a horizontal line that is crossing y at that number. Okay, now the reason why it's horizontal is because we only have one condition. We have the condition that y be equal to b. Now along this line, if I were to find other dots, let's say that that dot right there represented 4. Sure, the x has changed to a 4, but the y value, how high it is still at b for whatever b happens to be. And so that's why if we have y is equal to some number, it just goes horizontally, always keeping that exact same height on our axis for y being equal to that number. Similarly, if we do it with x, so we see that we cross the x-axis at that number a, and it maintains itself a units forward, because x-axis is always about how far to the left or to the right. So if we're at a positive a, we're going to be a units to the right. Now, our line is going up and down. It can change how high or low we are. This equation doesn't care about y. It only cares that x stay at that exact value of a units to the right. Okay, so it creates a vertical line. So let's do a quick practice. We want to graph y is equal to 4. So there's a good quick dot that I can figure out for this. So on my y-axis, I would go to 4. There's my first dot. And remember, the only criteria for this equation is that y is equal to 4. Well, if I draw a dot right here, the x is a 1, but y is 4, so it meets the criteria. X could be 2, so long as the y is a 4. So everywhere along this horizontal line, y will equal 4. So we've now graphed that equation. For x is equal to negative 2, well, along our x-axis, we can find where negative 2 is. And similar thing, but this time, I'm going to go up rather than over. So the y has turned into a 1, but that doesn't matter because the x value of this new point is still negative 2. X value of this point would also be negative 2. And once again, that's all that particular equation cares about. Now, what we have here is what we have right here is a x-intercept. Okay, it is where this line is crossing the x-axis, and it is crossing at the -2. In the other one, we have a very clear y-intercept. Okay, we are crossing at the value of y is equal to 4. Okay, now what we are going to do is a lot of our lines are actually diagonal, and they're going to have both an x-intercept and a y-intercept. Okay, and we want to find those values. These values are going to make it easy for us to make these graphs really quickly. Okay, so x-intercept of a graph is the x-coordinate at the point where the graph crosses the x-axis, and it occurs when y is a 0. So let's even look at the x-intercept they've drawn right here. So our x-intercept is right here. And notice what the y value would be. The y value is going to be at 0. Okay, similar thing, but switched for the y-intercept. It crosses the y-axis, and that value is going to be where the x is equal to 0. Okay, so to graph a linear equation that is in the standard form, what we're going to do is find the intercepts. And notice they gave us a big hint. Just to find the x, change the y to 0. To find the y, change the x to 0. Okay, and then draw a line that passes through the two intercepts. To find the x, let y equal 0. To find the y, let x equal 0. Okay, if I repeat it, it's probably because that's a key piece of information to pay attention to. So let's go ahead and do it. Let's find the x-intercept of this equation right here. Now, to find the x-intercept, what we do is we change the y to a 0. I want to find out what x is when y is at 0 in this equation. Well, 4 times 0 is just going to be 0. And then anything plus 0 would just be itself. Okay, so we got 3x is equal to 12. We want to get x alone. Divide by 3 on both sides, and we will have x is equal to 4. So notice two things. X is equal to 4 when the y value was 0. So that's a very specific point, 4, 0. And notice it's on the x-axis on our graph. Okay, let's find one more. Let's now do the y-intercept. Okay, so the y-intercept is going to have us do the same thing, but this time with x being a 0. Okay, so 3 times 0 is just 0. Anything plus 0 is just going to be itself. So now we just need to get the y alone. Let's divide both sides by 4, and we get y is equal to 3. So when the x was a 0, the y was a 3. And that gives us another point on our graph. Now, what we can do with this information is draw a straight line. So normally, as I'm working on paper, I'm just going to grab another piece of paper to help me draw a nice, perfectly straight line through both of those. Since I'm on a computer, I'm going to go ahead and use some of the tools I have access to and do my best to kind of go through both of them. And there's my line. Okay, so just by finding those 2 points, by multiplying by 0 and adding by 0, which is some of the easiest things we can do, we're able to quickly find those points. All right, so let's see this in an application setting. So you must feel pretty special because you are planning an awards banquet for your school. You need to rent tables to seat 180 people. There are 2 table sizes available. Small tables will seat 6 people. Large tables will seat 10 people. The equation to model this is going to be 6x plus 10y equals 180, where x is the number of small tables and y is the number of large tables. Now they want us to graph this situation, so let's go ahead and I'm going to kind of do this with quick work. I'm just going to do a single table, and I want to know when x is a 0 and when y is a 0. And in this way, I can find my y-intercept up here, my x-intercept down here. And all we really need to do, we can quickly figure this out. I'm going to put 0 in for x. So if x was a 0, then that whole 6x is just a 0. And then 0 plus 10y would just be 10y. So then I've got 10y is equal to 180. Divide it by 10. And I've got 18. Okay. Then let's do that again, this time with the y. So if I change my y to a 0, it'll be 10 times 0. Well, 10 times 0 is just 0, so that whole thing is 0. 6x plus a 0 would really just be 6x. So we can see this equation as if it were 6x equals 180. So divide both sides by 6, and we would get x would equal 30. All right, so great. We just found our intercepts. We can put them on our graph. So when x is at 0, y is up at 18. And then when x is 30, y is at 0. And so now, once again, I need to draw a straight line through those 2 points. And now we've got our graph. Okay, so using this, I'm now going to find what we call lattice points. The lattice points are where my line I've just drawn crosses these gray lines perfectly. Okay, so for instance, I can see that my line I just drew crosses right here perfectly. Now, the reason why I wanted to cross those gray lines perfectly is because my gray lines are very specific numbers. So I've got a 20 for the x, and that would represent a 6 over in the y. So this would mean I could seat 180 people using 20 small and 6 large tables. Okay, and we can do that. We can see other points where we also see it. Okay, so I could also do 7 and 14, which would mean 7 small tables and 14 large. And this could be another way that I would seat my 180 people. So now that I've gotten that line drawn, I can see a whole bunch of options very easily. I hope this helps you. Good luck.